Okay, so today we're looking at two-way tables. A two-way table is just another way to show your information. So like we were looking at the Venn diagram, when you have two events, okay, we can show the information in a Venn diagram or a two-way table. One thing to note that sometimes in worksheets, two-way table might be called something called a Kavanagh table. Just another name for it, but same thing. Okay, so for this Venn diagram here, okay, we've got events A and event B. Okay, so over in the two-way table, we can also show event A is up here and event B is on this side. Okay, so the same information, just in a different way. So just looking through this definition, two-way tables use rows and columns to describe the number of elements in different regions of overlapping events. Each row and column sums to the total at the end. Okay, so with this two-way table, we've got, so you might get A or you might not get it. Remember that little dash means not having A. And over here, you could get B or you could not get B. They're the two options here. Okay. And what this then means, let me use a different colour. So this 4 represents let's say people, 4 people have A and B. Okay, so that represents this little bit here. Remember, that's our intersection, that upside down U, which is 4, which is the same as our Venn diagram, that 4, how it's in the middle. Okay, so A and B, what it has in common is 4. Okay, so let's go a different colour. Let's look at this 10 here. This 10 means that it's in A, because see how it's in this column A. Okay, but it's in the row of not B. So there has to be the number 10 in A, but not in B. So if you look over at our Venn diagram, see how this 10 is in A, okay, it's in this A circle, and it's not in B. So that's why that is the same here. Okay, so it's in A, not B, so that's obviously A only. Okay, there is a lot of wording here, but it's important to get this into your books. Let's look at another one. Oops, we've done that colour. Okay, this 6 here. So it's in this column, so not in A, but it has to be in B. Okay, so something that's in B and not in A, so we're talking about B only. So if you were to look over at your Venn diagram, the number in only B is 6, which is correct, same thing. Yeah. And then this final one, let's just go black, 3. Okay, that means it's not in A and not in B. Okay, so this bit, neither A or B, which is the equivalent of our Venn diagram of that number that you put outside. Okay, is that 3. Now, it's important to note, just like here, it says each row and column sums to the total at the end. So we've got 4 and 6 equals 10. Okay, going down, we've got 4 and 10 is 14. 6 and 3 is 9. 10 and 3 is 13, so that's all good. And then you should end up with a total here, and both your row and your column should equal that. So 14 plus 9 does equal 23, and 10 plus 13 does equal 23. So you know that all your numbers are correct. If you're not getting all these sums right, then there's something wrong, you've missed something. Okay, so that's what we're looking at today. So really important you get this bit in your book. Let's just do an example with a proper example, I guess. So this one, we've got a okay, so the Venn diagram shows elements A and B. Okay, transfer the information, so we're doing A, from the Venn diagram to a two-way table. Okay, so mine's going to be a bit not neat because I don't have a ruler. So we're going to go like the other one was, A, not A, B, not B. Okay. First thing I might do is this one, the intersection. So 1 is in A and B, so 1 will go here. Then let's look here. This 2 represents A only, so not B. So I'm looking here at A and not B, so the 2 is going to go here. Okay. Then this 6 is in B only, not A. Okay, so B, not A. So the 6 will go there. Okay, this last little square is not A and not B. So what's in none of them, not in any of them, will be 3 because it's outside here. So there's 3 here. Okay, so to finish off, we need to add up all our rows and columns. So 1 plus 2 is 3, 6 plus 3 is 9, 1 plus 6 is 7, 2 plus 3 is 5. You can, put all of your little lines. Okay, making sure that this last bit, so we've got 7 and 5 is 12, and 3 and 9 is 12. So I know that I've got that correct, so that's really good. So I'm going to, no, let's do it. Okay. So for B, we want, what's the number in A and B? Okay, it's 1. A and B, so it's 1. 2, B only. Okay, B only would be 6. A only is, let me just get rid of, hopefully, good. So yes, A only would be 2. For 4, neither A nor B. Neither A nor B is, so not an A or B, is the 3. 5, what's in A? Okay, so the total of A, we need to count this 1 here and this 2 here, which is the 3. Okay, so you can look at, I guess this one is A, all of A, which is 3. Okay, 6 says not B. So not B, if we look, this is our not B here. Okay, so at the end of this row will tell us the total of not B, which is 5. Yeah, and last one, A or B. This one's a little bit trickier. A or B is going to be the ones that include A, the ones that include B, and the intersection. Okay, so it could be this is A only, this is B only, and this is the intersection. So you can add all of those up. So you've got 1 plus 2 plus 6, which equals 9. Okay, what you can, actually no, I'm going to leave it there. Okay, so you've got to add those 3 to get A or B. Okay, one really last bit. So the C, I. So find the probability of A intersect B. Okay, remember the intersection is A and B. Okay, over here, we know that it's 1. We can tell that it's 1 from here or 1 from here. Okay, so The probability is 1 out of how many altogether? Well, this 12 is the total altogether. Okay, so it's going to be 1 out of 12 is the intersection here. The probability of getting an intersection. Okay, the probability of not getting A. Okay, so how many is in not A? So we look over here. This is the not A bit. The total of that is 9. Okay, so that's going to be 9 out of 12 because there is 12 in total, which would simplify to 3 over 4. And yeah, we've already done A only, so that's it.